you get a beer, and it's going to be, you're going to have to catch me wherever I'm hiding at the party tonight, and I'm going to have to remember who I've given the beer to, because otherwise I think I'm going to be really out of pocket, especially if I drink too much. So so the idea is that some of the slides are going to have a speech bubble on it, which allows you to win some beer, and you just have to answer the question. Now, I'm not going to take all the answers, otherwise I'll be buying everybody beer, but I'll take the best answer. Yeah, that's it really. So when you see that win beer bubble, that means that there's a question up for grabs. So at least be alert for those slides. So the goal of this talk is, it's not very technical. It's actually really high level, and it's kind of funny for me because my day job is breaking into things and doing incident response. But the whole cloud thing got me really thinking just over a year ago about really what that might mean for the future of some of our jobs. And so I was kind of intrigued also by what shiny new attack surfaces are also available. And so really the goal of this is to get you guys thinking, and specifically I'm going to point out some areas where I think that there's some real good scope for doing research. And so this could be research that, next year you come back and speak at BruCON on these things. There's a lot to go through, and I'd really encourage you to give it some thought. That's the agenda, and I won't read it out. But first, before we kind of go into it, why bother talking about cloud? Like, what is the significance? It's the famous "so what" question. So a couple of slides before we get into the more interesting stuff. Our business leaders, in this case the CFO view, they're interested in that right-hand column that, notably at the very bottom right on the balance sheet, if you're paying for cloud services rather than purchasing equipment to run in your own data center, then nothing appears on your balance sheet, which is kind of, good for certain people that want to invest in your company, maybe. And the other point really is just people make a big fuss about, like, is an item capex or is it opex? That's not really. I mean, if you speak to financial people, they generally say it doesn't really matter. So the whole kind of the sort of cloud marketing that talks about it's opex rather than capex isn't such a big deal. But pay as you go, CFOs like good cash flow, so that definitely helps. The CEO view, the CEO looks at it from an agility point of view. So cloud doesn't necessarily save you money, and the CFO knows that. But the CEO is interested in being able to execute faster. And what do we mean by that? Well, everything's super competitive these days. Everything's down to a niche, and so our employers are battling in markets where they want to be first. And they go and speak to their IT team, and the IT team says, yeah, 4 weeks to provision that server that you need. And then they read about, Amazon EC2, and they can have someone provision a server within a few minutes. And suddenly these guys are thinking agility, and that's the big word with cloud. So that's the sort of senior management view. The downside, of course, just with anything, but especially with cloud juice, is if you drink too much cloud juice, you have a very familiar feeling, at least it was to me when I was a student. And you tend to sort of see things slightly differently. And the realistic view on cloud is that very few established companies that have any kind of data center will be jumping both feet into cloud computing. So they may well look at certain workloads that they run and look to see which ones of those might be suitable for putting into some kind of public cloud or private cloud, and I'll talk about those in a minute. But ultimately, even though the marketing engine might suggest everybody's going cloud, well, obviously they're not. They're kind of taking a step approach. Startups, on the other hand, it makes complete sense for them to be on the cloud. I'm not sure if it makes complete sense for a security startup to be in the cloud. That's tempting fate, I think, but at least at this stage. But not everybody's happy, especially if I think about my initial reaction and the reaction I get sometimes when I'm talking to info security people about cloud. Well, we're a pretty cynical bunch, and we've heard this is the next best thing. marketing too many times, and so cloud stuff just generally gets people's hackles up, and it kind of just annoys people like us because we just think, yeah, it's just Groundhog Day. It's just going to be, you know, the same problems just in a different guise, and definitely there's a lot of truth in that. But because, you know, what we do, many of us defenders, then we have to think about, okay, well, when our companies start going out to the cloud, what sort of things should we be doing? And this would be competition time. This is our first question of the day. Can anyone name this person? Put your hand up if you know the answer. At the back there. Very good, yep. I owe you a beer. Right, so Jeff Bezos, he's an important man in the cloud, and that's why he's smiling so much, unlike Grandpa Simpson, because he's the guy that started up the Amazon Web Services business, because obviously he's the guy that runs Amazon. And what's interesting is that a lot of people have compared cloud computing to utilities services like electricity generators. They've said, well, we want our IT on tap. We want to be able to consume it when we want it, and we don't want to have to own the equipment. And that's the whole premise for, certainly for a certain segment of the cloud wannabes. And but what's interesting is that Jeff Bezos is actually standing at the very back there. He's got the suit on, the dark suit, and he's actually standing by a Belgian electricity generator that was from a brewery. So, you know, even though it's a small thing, unearthing things like this really tell us that Belgium's had more perhaps to do with the cloud than people have given it credit, especially that Nick Carr guy with his best-selling book. So anyway, quick definition recap. Already mentioned, you know, architecture. Wow, yeah, cloud's in full thrust at the moment as far as painting a vision that doesn't necessarily exist. And I mean, there's been interesting cases where even good, let's say reputable kind of companies that offer cloud services are saying things like their cloud is PCI compliant, which, you know, if you go through the PCI stuff, it's like a public cloud, PCI compliant. That's pretty much impossible based on the criteria. And then what you find is that it's their marketing department is out of sync with their operations people. You speak to their operations people and they're just like, yeah, we kind of really messed up on the marketing. But there's a lot of this, and so again, we have to kind of rise above it in order to see what the real issues are. Otherwise, we're just going to write it all off as, yeah, it's a load of mumbo-jumbo. But I think it's too important to write it off like that. But of course, if we just talk about cloud, you can't have a meaningful conversation, because what does cloud mean? I mean, obviously in the past, it meant your network over there, well, not really your network, but the rest of the network, so perhaps the public internet or whatever. And that's what we're used to on our network diagrams until this raging cloud vehicle decided to pick up the term. And the problem is that if you talk, you know, if you walk into a Belgian bar and say this, I mean, who here is from Belgium? You're not all getting beers for putting your hands up. So if you walked into a bar and said, "Oh, just give me a beer," what would the reaction be? Sure. Oh, well, I like this country even more. But the reaction would be like, well, what kind of beer? You know, because you're in a country that loves beer and they know how to do beer. And so if you walk in, you know, you sound like a bit of an idiot. And the same is true of cloud, because when we talk about cloud, you can't have a meaningful conversation about a word that's like cloud. Yeah, because it's just so damn fuzzy, it's ambiguous, what are we talking about? So until we can sort of define what we mean and really try to have some kind of lens through which to start asking perhaps the tough questions and thinking about attack surfaces and everything else, we can't really move forward. So would somebody like to tell me what this authentic Trappist product seal is all about? Why did this come about? Now, there's lots of people from this country here, so quality. But what was happening? What was happening in the market that meant they came up with this? Fakes. So everybody was claiming that they were making Trappist beer. So, right, you get a beer for that. So the thing here is that just like the Trappists had to effectively kind of define what Trappist beer was, so what does that really mean? It's the same with the cloud providers, and at the moment they're doing a really bad job of it because they've all got slightly different definitions, but that's because it's so young. But in 2 years' time, I think we'll see, we'll see certified clouds run by certified cloud idiots. And the point being that there's already companies like IBM Global Services are already offering like certification of clouds. It's like, how can you certify a cloud when we don't really even have any standards yet? So what's the benchmark for that? So it's obviously just what IBM feels is right. Now good luck to them, but it's hard to create a certificate when you don't even have established what is the standard. So just quickly on cloud properties. This first one is pretty key. You can't really have. So let me just step back. The reason why I'm talking about these 5 things is that when somebody says to you, "Hey, we're cloud enabled now. We've cloud enabled our products," then you wanna kind of just run through these points and just say, right, well, is this product or service they're talking about, does it exhibit any of this stuff? And in fact, it should exhibit more than just a couple of the items. It's not you can't say 100% this makes it a cloud, but there seems to be general consensus in the cloud community that these are the things that mean that something really is kind of cloud. So the first one is abstraction of resources, and we know that best through virtualization. But unfortunately, everyone kind of gets, when you talk about cloud security, like the first question most people ask me is, "Oh, are you going to talk about virtualization security?" And it's like, well, I'll mention it, but because it's relevant. But virtualization does not equal cloud, and cloud does not equal virtualization. Virtualization is just one way to abstract resources. If you speak to Google, they don't use virtualization. The word that, I don't know if they would use this word, but the word that I would use would be, it's more like a fabric. So they have all these machines and they've custom coded a software layer that goes above it, but they're not using virtualization. It's still an abstraction layer because they can remove machines as they fail, and it doesn't affect what's going on as far as operations. The other thing is it's on demand. It's not a cloud if you have to call somebody up and they say, "Yep, we'll provision that for you on Wednesday." Yeah, that's just not. You've got to be able to do it without interfacing with a human. Yeah, and you've got to be able to do it. Really, that means with some kind of payment instrument like a credit card, where you can just do it. So that's another aspect. Elastic. This is always a good one. What does elastic really mean? Well, Amazon Web Services, they pride themselves on higher utilization levels than your average data center. So your average data center, they say, averages about kind of 20% usage, and in terms of compute resource used, they're running at like 50%. And that's because what they say is that all the demand from their different customers that are in different industries kind of all combines together, and it means that they can smooth out. So, but elastic means that you can shrink, not just, oh, can I have 10 more virtual machines, but it also means I want to give back 8 of them because my peak load kind of finished. So that's another one. Scalable, that should mean that you can keep asking for stuff, like I want more compute power or I want more storage. And of course at some point that has to run out, but it should be to the point where you don't have to think about it. And that's the kind of magic that the cloud providers are doing, but ultimately at some point that will fall down. The other thing is it has to be API driven, so this comes back to not having to interact with humans. There should be some kind of published API, and really through that API you can do everything that you consume the service through the API. And then finally, stuff tends to get referred to as something as a service. So infrastructure as a service would be an example. So those are the things to remember about cloud, and that's what makes it different from dedicated web hosting, or even shared web hosting, or any other things. Even it's different from utility computing. So it's a combination of different things which have these properties. And that's kind of where the problem comes. Generally, you're not meant to land aeroplanes with the brakes on, but I guess this pilot did. And the problem that we have straight away is that if you think about a dynamic environment where resources can be moved around from one data center to another data center, and you don't necessarily control that, then you're like, all of a sudden, well, this just turns our network security model upside down, because we're used to, that machine is there, it has perhaps some network security devices around it that have some fixed network addressing attributes. There's probably some state that's being maintained, and and if you suddenly move, if you kind of motion a hypervisor to somewhere else in the case of infrastructure as a service, then, well, what happens to all that kind of metadata about where it is and it's been moved to another part of the network. And I think the problem we've got right now and what the vendors are working on is trying to figure out how you still maintain security in the event that something just moved to a completely different place, so now has a different context. So that's kind of just the immediate obvious thing they need to solve. Now, this would be another opportunity to get a drink tonight. The most common thing I hear about cloud is people say, not necessarily technical people, but people say, well, it's just outsourcing, isn't it? We've always done outsourcing. Cloud is just outsourcing. Now, I'm interested to see if any of you have a view on why cloud is not just outsourcing. What's different? So in other words, where you might have outsourced to a dedicated web hosting provider, just to use that example, and now you're going to a cloud provider, and let's say you're a large enterprise, so you kind of care a lot about security. Any reasons why cloud isn't just outsourcing? Why we don't just manage it with a contract? Just. Any thoughts? There's a beer going. I'm going to be drinking it. All right. I don't think anyone put their hand up there. Okay, you could have guessed. I mean, that was probably worth a guess. The main reason that I would give is that with outsourcing, you can go and visit the outsourcer. Okay, and that's one of the key things, that you can actually go and talk to their system administrators. I'm assuming you're a reasonably sized customer. You can go and talk to them. You can give them your 500-cell Excel spreadsheet with all the questions on it that they have to answer, cut and paste from their internal stuff, and you can have that. You can have a conversation with them. With the cloud stuff, unless you're a huge customer, well, they're not even going to tell you where the data center is. Like Google doesn't publish where their data centers are, and I think that with outsourcing, you have a greater sense of what's going on with the systems. You may not own those systems. Sometimes you do, but mostly you don't. But you have a greater sense of what's going on. With the cloud, we're kind of being offered a black box, and it's like, here's your API front end, and we'll look after everything at the back end. You don't need to worry about it, honest. But the truth is, there's no cloud magic when it comes to security. And even though they've built these cloud platforms from scratch, from the very, from a clean piece of paper, unlike a lot of our enterprise systems, that doesn't mean that they've kind of suddenly solved all the security problems that we deal with in the enterprise. And that's the thing to bear in mind with this. It's not that there was the best security people in the world got together, sat down and said, yeah, we're going to do cloud security and we're going to make it right this time. No, they didn't. I mean, they were companies that they have a business model and they're trying to set something up quickly, so they did whatever security their customers asked for, which, on average, we could say isn't going to be very much. It's only going to be people with, specific requirements. So let's just quickly talk about the cloud types, because this is where we can have a meaningful conversation about something that isn't just a cloud. So the first thing is that a particular cloud type is based on a platform, and platform's the fancy word that just says a provider creates a platform, then there can be like an ecosystem around it, and people can plug into it, and that applies to security products, normal IT products, everything. But with cloud platforms, what they've done is they've basically stitched together a whole bunch of different open source software from all over the place, welded it all together, and said, right, we have a cloud platform now. We have an API that can be called. We have probably some middleware that shoots off messages to the relevant back-end systems. We have an orchestration layer which is responsible for how the resources get moved around and everything. And so if you just imagine, like, if any of you pen test or whatever, or just trying to maintain systems, you know what it's like if you have loads of different libraries, and you kind of you can get yourself kind of twisted up really fast, and trying to actually keep all these up to date. Like if you've got OpenSSL, you generally want to keep that up to the latest rev. And what they've done is they've kind of got this stew of open source software, and they're doing that because they don't want to pay license costs, fair enough, and because in most cases it's easier to glue that together and do what they want to do. But the thing to remember is that there's a cloud platform which is basically brand new software. So what do we know about brand new software and security? Do you have maybe a sense of, it's kind of a very interesting proposition that we have such a big attack surface, and such a new attack surface. And we haven't even talked about hypervisors, because hypervisors are becoming commoditized. They're becoming much smaller. Like if you speak to VMware, for example, they've intentionally shrunk down the code base of their hypervisor, and so a lot of that function has gone out to the management tools and middleware and stuff like that. So the hypervisor, whilst it's really interesting, if you find a 0-day in a hypervisor, wow, you're gonna own a lot of boxes. If it's the Zen modified one on EC2 on Amazon, wow, you're gonna own a lot of stuff. But ultimately, there's just the hypervisor is this, and then there's just this big umbrella of like new stuff. And so the open source software may not be brand new, but the combination certainly is, and they're probably using it in interesting ways, which might lead to some openings. So I'm going to talk about 3 layers here. Or I put the red bar in the wrong place. That's meant to be infrastructure, platform, and software. So we talk about infrastructure as a service, platform as a service, and software as a process. Software as a service even. And infrastructure as a service. What do we mean by that? I'll give a beer if someone can tell me what infrastructure as a service is. That's an unofficial beer question. I just threw that in there. Anybody? What's infrastructure as a service? Yeah, you can get a new server. So you can spin up, in this case, it tends to be a virtual machine. You can spin up a virtual machine on demand. Okay, so beer for you. You won't be here? Great. We've got spare beer going. Oh yeah, all right, thanks. Chris was just jumping up for that beer. Now, platform as a service. So, as an example, like Amazon EC2, that's infrastructure as a service. So, platform as a service. Anyone know what platform as a service is? I think the guy that's sleeping there, I think he knows. Nobody? Platform as a service? Oh, yep. Say the first bit again, because I'm not sure I heard you.
You get software and you only get access to the administration interface and somebody puts updates.
Oh, okay. Yeah, that's kind of more the next. That's the next one. That's more like software as a service, really. Platform as a service. Have you heard of Google App Engine? Google App Engine? Yeah? Not really. So Google App Engine, that's what's called platform as a service. What does it mean? It means that it's a development platform. So in other words, you would code some application, perhaps on your own machine or on their kind of platform in the cloud, and it would run on their servers. So instead of having to manage the operating system like you would with infrastructure as a service, like with infrastructure as a service, you've got like a Unix box or a Windows box or hundreds of them, and you have to manage everything. You're responsible for the security of the host. Platform as a service says, look, we're going to hide all of that stuff from you, and you only need to worry about think as a developer. Yeah, so we're going to make a whole bunch of like interesting developer APIs available to you. So we're going to give you like a database store that you can access via an API. So platform as a service, Google App Engine is a great example. And then software as a service, that would be like Salesforce.com. So it's people always say, well, isn't that just ASP? You know, in the old days there was ASP, which then suddenly became software as a service, and people were like, well, what changed? And the best definition I could find was that with ASP, if I was your ASP and you're running some financial application, I would basically build out a whole dedicated environment for you, take your software, run it on there, and configure it just for you. And you'd have that dedicated physical set of machines and that dedicated software. With software as a service, it's multi-tenant, which means that we're all sharing, all my customers are on the same set of machines. And that's quite a big difference. Like infrastructure cost, it's a lot less money to do that. So that's why they can charge fairly reasonable rates for software as a service. I'm not going to go through this, but you should check it out, because this is something that Chris put together, and he actually did it over Twitter. So it was like loads of other cloud people kind of chirping in with different things, and it's actually a really good way to look at cloud and sort of to understand the layers, because it's again cloud being a fuzzy subject. So I just encourage you to actually look at that offline. I'll bore you to tears if I go through it, and then you'll say I haven't talked about security. So quickly on the Jericho Cloud Cube, hands up. Who? This isn't for beer. Who knows the the Jericho forum. Got a few people. Okay, so about half a dozen people. It's a UK-based group that is large enterprises that have come together to try and solve some of the collaboration challenges that they see. Like, how do two large enterprises share data, in a confidential way? That's doable. But what happens if you've got 20 large enterprises and they want to do this? And so, I mean, they've done more than that, but that's kind of what they started with. And so what they did quite helpfully was put together this model, and there's 3 dimensions. You've got, is the cloud external or internal? So is it running in my data center? So is it a private cloud? Or is it external? So is it like it could be with a third party that runs it just for me, but it's definitely not within my perimeter, or sorry, within my data centers. Then you've got another dimension which is proprietary and open. Well, we know what that is. People like Amazon, they built a proprietary platform, so all their stuff is proprietary. Yes, they're using Zen as the hypervisor, but there's a lot more than just a hypervisor. They had to create a billing system, and it turns out billing systems are really, billing at scale is really hard to design from both an operational point of view and a security point of view. So when I talk attack surfaces, it's like brand new billing systems that were created from scratch. The other dimension is whether it's perimeterized or deperimeterized, and that really just means, is it within your network domain or is it outside? And that's really whether you would need to connect via VPN to a cloud or whatever. So this cube is just a useful way to kind of, if someone's going to talk to you about cloud, first thing you say is, well, what layer are we talking about? Are we talking about infrastructure as a service, platform as a service, or software as a service? Because they're 3 very different beasts. And then you say, well, is it going to be external, internal? Is it open? Is it proprietary? Is it within my perimeter or outside? So straight away you've managed to kind of zone it right down to something that you can ask meaningful questions about. So here's an example of a public cloud as an alternative to keep talking about Amazon. This is Microsoft Azure, and they do a kind of software and services model. Obviously they do software because they want some license fees to continue. But if you look at this, the developer, who's unfortunately got no arms, he's at the bottom there. He's the guy just shoulders, head. He or she is creating software in Visual Studio that's kind of been cloud enabled. And then when that's ready to rock and roll, pushes it up to the Azure platform where it executes. And it can interact with a whole bunch of web services that Microsoft offers. And so what's the deal with the public cloud? Well, it's public. Yeah. The API endpoints are accessible to anybody on the internet. So, that can be good or bad. And there's no beyond the terms of service and SLAs. There's no bit that's yours. There's nothing which says this segment of it is yours. They are going to manage the back end, and your data could be kind of anywhere in their data centers. Virtual private cloud. Amazon, a couple of weeks ago, just announced this. They've taken their public cloud, realized that a lot of customers they're talking to are saying, we want something a bit more private, but we don't want to run it in our own data center because we don't want to buy all the equipment. So what they did was they said, all right, we'll take our public EC2 service, and instead of plugging you can only have one network interface card on an EC2 virtual machine. It's just the way they've set it up at the moment. So I think all they're doing, based on the description, they give no technical data at all. They're just reading between the lines. It looks like all they do is they switch the NIC from being in the public EC2 service to being in some kind of basically private network, which is then attached to you via a VPN. So what's the attack surface? The attack surface is the virtual NIC driver. It's a pretty small attack surface, so it could be quite hard, I would imagine, to kind of escape from either a public EC2 and jump into somebody's virtual private cloud. But that's the level of sharing we're talking about. If you think about shared web hosting, it's kind of like really similar to that, except for you've got, instead of the security being at the process layer, which it is with shared hosting because you're all on the same machine, with virtual private cloud and public cloud, it's at the virtual machine level. So, yep. And then private cloud, this is what VMware, Cisco, EMC, and others are currently marketing big time, which is you convert your existing data center into a private cloud, which means that you've abstracted the resources, which means that the workloads are no longer tied to a particular machine, where you could say, well, that's just virtualization. But then there's this orchestration layer, which means that you can motion virtual machines across, and even more importantly now, they've got the hooks for external clouds, so that if you want to push your test and development workloads into a public cloud, because you say, well, that's not very sensitive to me, because I'm not going to put any customer data there, I promise, then you can, this is going to allow you to do that. So that's just definition of private cloud. If anyone says to you, come quick, do a security review. Quick one on this, government clouds. The US government just announced apps.gov. And for those of you that have got iPhones and access the App Store, this is like the government cloud version of that. So the idea was that the new CIO over in the US wanted to reduce a lot of bureaucracy around how other bureaus would kind of get resources. So they came up with this. And but so I don't know what my government's doing. Does anybody know so if you're not from the US, does your country have any stated strategy around cloud that you've heard of? Because that's the only one I've really come across. No, everybody's shaking their heads. Then of course there's homebrew cloud, and this is a real photo from the internet, so it must be true. And this guy brews all his beer, and for some reason keeps it next to his open computer and disk drives. I have no idea, but I just included it because you can actually download a cloud platform. So Canonical, the commercial support people for Ubuntu, you can download cloud software. You can literally have your 5 machines at home, and you can put cloud software on there and run your kind of mini private cloud, which I'm encouraging people that want to do vulnerability research. That's a great way to do it without getting into any trouble. So, but you see all this stuff. You see these diagrams with crazy graphics and clouds and platform as a service, infrastructure as a service. It all sounds a bit gobbledygook. And as Douglas Adams once said, very wise words for many situations in life. Don't panic. And he's right, because if we look through, which layer are we talking about? Are we talking about internal, external, proprietary, blah blah blah? We can get to the point where this is something that's kind of closer to what we know. So what are the concerns? And there's some really obvious ones, so I'm going to go quickly through those, but I kind of want to include them in case people haven't really read anything on it. And what I'm trying to do here is focus a bit more what's cloud specific, because there's a lot of concerns which are not cloud specific. They're just like IT security in general. So this is just to the point that you can't go and visit a Google data center. So if your company who is being courted by Google, because Google's talking to lots of enterprises, unless you're a huge company, they are not, as I said already, they're not going to invite you to the data center for a cup of tea and a sit-down chat with the administrators. So let alone going into the basement. So you're potentially never ever going to see the place where your data is processed. And even if you did, because the data centers are, they're not in their own clouds, it's like one fabric, it doesn't really matter, because your data, is likely to be copied to multiple places just for resilience anyway. So this initial thing of can you let go enough to allow that to happen, which is kind of, for security people, a really kind of big psychological jump, really. The other one is uptime. I've never seen so much hot air on the internet, except for when Gmail goes down, then Twitter nearly goes down because everyone's saying, is Gmail down? And the same for when Amazon EC2, when their cloud crashed, same deal. Everybody's really worried about uptime, and in the SLA they generally only guarantee 99.9%, which a lot of enterprises say, that's ridiculously low, we do 5 nines. But when you actually work in enterprise, you often think, well, maybe 99.9 isn't so bad after all. So I kind of think this is a bit of a red herring, but a lot of people like to talk about uptime as a big issue. Lock-in, so this is let's look at the 3 layers again. If you're doing infrastructure as a service, what is the lock-in? Well, you're operating on a kind of virtual machine level, so you need to be able to get your virtual machines out of that provider if you choose to go to another provider. So the lock-in is if they don't provide a way for you to get the machine out, or if the format is specific to that provider. How do you port your virtual machine over? So, there is an initiative, the OVF, which is trying to define a standardized virtual machine kind of format package. But platform as a service, that's the worst one. That's really the ultimate lock-in, because you have lock-in at 3 levels with platform as a service, which is, one is that let's say with Google App Engine, you've coded some Java application. Your CIO is really happy because your Java application should run, you should get to debug that everywhere you choose to run it, not just on Google. But the thing is that you're coding to their back-end APIs. So you're coding to Bigtable, which is their data store API. That's the name of the software, but you're coding to that. So you're not doing relational database lookups. You're doing kind of the Google version of database lookups. And then your data's in there as well. So you've got really these 3 levels of lock-in. That's not necessarily bad, and I'm not saying you shouldn't use Google App Engine, but it's obvious that before you start putting too much stuff in there, you need to think about, well, what's your exit plan for the day that the Federal Trade Commission decides to shut down Google App Engine for a week or something, which they're under quite a lot of pressure to do. Not specifically Google App Engine, but a whole bunch of Google services. Software as a service, you could say that's the ultimate lock-in, but it's not, because there's enough players that there's competition. You can say, right, well, one of the things that software as a service providers are really keen on doing is showing how easily you can get your data out. Multi-tenancy, this is really just like shared hosting gone nuts. And why is this interesting from a security point of view? When you're designing a shared system, you have different layers that you can do the sharing at. So one layer would be, I'm going to give you a dedicated back-end database. So George, all your stuff, all of your business's data goes into that database. Well, okay, so if someone does like a SQL injection attack, they're going to have to do quite a lot to get out of that database. Depending on how it's configured, but only one customer's data is exposed. Whereas if you are in let's say a shared database, but you've got your own schemas, so there's kind of a different namespace for each customer's data. In that case, they're kind of closer because they're obviously in the same database. They need to figure out, the other customer's schema and if they can access it. But where it tends to boil down to for performance reasons is they just put all the customer data in like a single table for a particular type of object. So you end up with all the customer records in the same table, just separated by some kind of customer ID. Now, this isn't new. This is how a lot of websites have run for years. That's the way they've been designed. But of course, when you talk about a SQL injection hole, then suddenly it's a lot easier to get all the other customers' data. So, even design choices like that, which the cloud providers are making on your kind of behalf, and they're kind of questions you would be interested in, because whenever you invest in a new technology or service, you want to know how resistant is it to attack. We all know that everything can be broken into, but kind of how easy is it? And so asking about multi-tenancy. Another one is change control. There's a quote from one of the senior vice presidents at Google where he said that one of his engineers once described when they make changes to the Google web search, it's like changing the car tire on a car that's going 60 miles an hour down the motorway. Yeah, and that, you suddenly think about that. Now, I'm used to downloading software, and if it's Linux software, there's a change log. Yeah, I can look at that change log. Oh, what did they change between version 1.3 and 1.4? Well, do you see? I don't see any change logs on Google or some of the other providers. Sure, they might tell you if they're doing something that will affect your experience with it. So if they change the user interface, but basically you've got like this, nuts change control going on in the background with all these moving parts, and they're obviously doing a pretty good job most of the time, because it's not crashing anything. But from just a boring kind of change control perspective, that's pretty significant, and the implications of that going wrong. And also from an assessment point of view, let's say that you agree with company X, that's a provider, I'm gonna hire a pen test company and they're gonna come and pen test your stuff. It could change the next day. Like, what assurance do you have that what you tested yesterday is the same as today? So that's another challenge, that there isn't much visibility around kind of version changes and changes like this. So when you think about gaining PCI compliance, I mean, that at the moment is a point in time, but they're looking at, okay, can they make it less a point in time and more a kind of, general thing? And I'd really be interested to see how they even think to do that in this environment. Visibility, really obvious. You only get to see what your provider lets you see. So you probably can't see, depending on the cloud provider and how they've coded the application, you can't even get basic security logs out of it. Yeah. So I mean, let's take Amazon for example. If you log into Amazon, if you make loads of failed login attempts, or someone tries to break into your account, you've got no visibility of that whatsoever. It's kind of scary, because that's infrastructure as a service, and if you're running a whole bunch of servers in the cloud and someone does successfully break into your account, then that's like they've suddenly got your infrastructure. So the lack of visibility in the cloud just around basic kind of checkbox auditing items that you'd expect to be in any kind of modern operating system, they haven't implemented that at the cloud. So I'm not saying that's everybody, but it's just you have to go through that really kind of dreary, boring auditor checklist kind of thing to say, well, does it have this, does it have this, what are the password policy controls, all that good stuff. And at the moment, because it's immature, and I'm not saying it's necessarily massively insecure, but it's just immature, so they don't have this stuff, and you'll just find yourself asking for stuff which, if you go to Amazon, if you go to the online forums, you've got all the people saying, when are you going to implement this or that or the other. They respond to some of it, but there's clearly people that have specific security requirements that aren't met right now. So cloud layers, pretty simple. If you think about how one cloud service provider delivers their service, and you look at the ecosystem around, that you've got this platform with these different third parties that hook into the platform in some way, you start getting services that are layered on top of each other. And what happens when you start introducing dependencies is you need to be able to manage those dependencies, and you need to know what risk level those dependencies introduce. And if you're an attacker, and there's effectively this kind of cloud supply chain where multiple providers are providing you a kind of API endpoint, then you're going to go after the weakest company, really, the weakest provider in that chain, and potentially it compromises, the data that you're sending through those other providers. So this is one of those ones where at the moment I would say it's still kind of early days. There's not too many services like this, but they do exist. But I think in the future it's going to be something really, it's going to be a big deal, because I think outages are going to affect people in ways they didn't expect, because they'll say, well, I didn't know you were subcontracting that part out to there. So it's classic kind of subcontractor concern with outsourcers, but with the cloud it's not always very obvious, and it's not written down. They don't say, oh, well, yes, when you do an API call to us, we're actually doing an API call to this guy over here. That's kind of where your data's stored, because we didn't want to code up that functionality, and they approached us and we said, yeah, we can hook into your API. So that's going to be interesting to watch. I think there's going to be lots of problems in that area. So identity, there's a lot I could say here, but I won't, because otherwise more people will fall asleep. So we haven't solved the identity problem inside large enterprises. Yeah, we may have single sign-on, but we haven't solved the identity problem. So we still have too many accounts. We still have problems reconciling those accounts, the joiners and leavers processes. And on the internet, is it any better? No, it's worse, because every website kind of uses their own authentication method and so on. So whilst there's definitely been some improvements lately, it's one of those things where you've just put the internet world and like the enterprise world together, because it's kind of the public cloud thing, and you're just looking at identity going, wow, how are we going to do that right? Now the good news is that there was a project called Project Geneva, and Microsoft had a lot to do with that. And so Microsoft right now, they actually have a way that you could use your internal AD credentials to access their Azure cloud platform. And just a random question, like that uses a plugin that goes into the PDC. I think that's right. So the random question would be, how many of your organizations someone's installed that like random plugin into PDC? How would you know that? But at that point, they can authenticate out to Azure Cloud Services, and there's this like really quiet grassroots use of cloud stuff in enterprises where it's not officially sanctioned, but people are just, it goes through the proxy that's not being blocked by the whatever proxy filtering software is being used. And so I think with things like this, it's another one where the developers will always go and do what the developers need to get done, and now they have an option outside of the IT department. And I think things like identity and credentials, and that's going to be really interesting to see what pans out there. But right now, there's, apart from Microsoft, really, it's not very. We haven't moved forward. So SLAs, I won't talk much about these, but go and read some cloud SLAs. These make really good reading. And also set up a monitor that checks that web page every day to see what changes. I can't believe. I mean, I get a lot of emails every day which are showing me, this cloud provider, they just changed their SLA or their terms of service, whatever. And sometimes it's just a markup change on the web page, but a lot of the times they're just tweaking. They're tweaking little bits here and there. So it's another one which, we all know the advice on social networks, read the SLAs before you join them. Okay, that's at the private individual level. But with cloud providers, you really need to read the SLAs. And the thing to remember is that you can negotiate better SLAs. Like most of them are open to talking about that. So if your company needs more, you can actually ask for it. It's just, there's no form there which says, tell us you want better than what we normally do. You'll pay for it, but that's kind of the whole point of metered services. Terms of service, this is the summary. Essentially, if they screw up, they'll give you service credits. Woohoo! That's really great. I'm really pleased about that. My service was down for 3 days and you gave me some service credits. Now, okay, that doesn't necessarily change much of what happens today with a provider, but the sensible cloud strategy is to actually use a couple of cloud providers at the same time. Like that's the only sensible way of going about using cloud services for anything important that you care about. But yeah, the change any time thing, that's really so true. They make full use of that. Legal issues, okay, I'll be quick on this one. This is a good one. So this was in Texas. 2 data centers got raided by the FBI. Nothing to do with cloud. They're 2 just standard data centers. And they just went in, took all the servers out of these 2 data centers. And what happened was they thought that all the servers belonged to this one customer. Oops. And there's this kind of comment here, which was that it didn't seem that the FBI understood the concept of co-location. So the cloud is the ultimate colo, yeah. And so you might say, well, that's not good, because if I'm using some cloud services, the FBI could come and do that. It's kind of the same as this situation. But can the FBI or any national agency, can they really now, in the future with cloud, can they really get the data? Because if you've got this orchestration layer that allows you to move resources within seconds over to somewhere else, well, why can't I just move these VMs that I've been using to do fraud on? That the FBI I know are coming to town to grab my VMs. I can just motion them over to another data center, a partner of this cloud provider. It could be another country. And so you kind of got this really interesting thing. Can they, everybody's panicking at the moment about don't use cloud centers because, search and seizure, and so particularly the US is being kind of singled out a bit. But the bigger thing, I think, is that the FBI won't be able to get that stuff, and nor will our other agencies. So I think that's going to be very interesting as far as how that changes investigations going forward. Of course, then there's the friendly auditor. This auditor has only just learned about virtualization. And now you're going to talk to me about cloud stuff. Good luck. So you, the customer, become the educator again, where you have to sit down with the auditor and say, yeah, so we're using the cloud, and we've got the SLAs and everything in place, and they're just like, well, what are you using it for? So you've got to have a good story to tell the auditor, but you've got to figure out which workloads are suitable for the cloud. So it's really common sense, but understand that the auditor is just going to be going, well, I don't see the system. Where is it? Yeah, and my only point there is just I think there's going to be a big learning curve, and so rushing out to stick stuff in the cloud is potentially going to burn you. And I don't mean that to be negative about cloud, but it just seems one of those classically difficult points. So the other thing is around pay as you go. So the idea is that you can pay for these cloud services with your credit card, and you've got to think that makes it really quite interesting for certain groups that perhaps end up with credit card numbers, because let's say at the moment they would go and buy a botnet, some time on a botnet. That's nice, it's like say 50,000 PCs or whatever. Well, if you go and look at the virtual machine sizing page on Amazon's EC2 service, they do like a high CPU instance, which has got 7 virtual CPUs, and they charge a bit more for that per minute, per hour, and you just start suddenly thinking, wow, it's kind of really going to be, it's great for pen testers because you can just have this password cracker in the cloud, and you can just spin it up and then shut it down and they've all disappeared. But you've got to think this is going to be really attractive to organized crime. Now, they will take a while to latch onto it, but for me, if I'm a cloud provider, I'm going to really need to be investing in real-time fraud systems, and some research that SensePost did, South African company, on cloud stuff, they were able to open up multiple Amazon accounts, the same credit card. They were doing really what would be suspicious stuff if you could actually monitor it, but Amazon weren't monitoring it. So even though Amazon as a retailer will have, I'm sure, very good anti-fraud systems, because they're the biggest retailer in the world, and you don't survive doing that if you don't have good fraud systems. It's going to be interesting to see how they actually push some of that technology into the cloud stuff. And I think it's going to be very interesting to hear about cloud companies that didn't do this right and just got completely ripped off. So another reason to be with multiple cloud providers, really. The other angle on this is denial of service. Since it's your credit card that's paying for your service, and I can connect to your service, then I can obviously consume resource, and you're paying for that resource. So there's an obvious denial of service situation here where I just run up the bills. I don't like your company. Your company screwed me over. I don't like your customer support people. So now I'm just going to really make you pay for it, literally. So you still might be able to do business. Why would you be able to do business? Well, because the cloud is scalable. So just, unless you've set some limit somewhere, if your provider lets you set some kind of soft resource usage limit, well, you're just going to keep, you're going to spin up automatically more VMs, so you're just using up more resource. Great. Someone's paying for it. Well, whose interest is it in to prevent this? It's not in the cloud provider's interest. It's making money. Data wiping. You can't do it. You can delete files, but you can't wipe files unless you install special utilities, and you're doing that within a virtual machine. But if you're putting data into an object repository in a cloud, there isn't could you really delete this API call? There's just the standard, unlink the name from the data. So there's currently, I'm not aware of any public cloud provider where there's any kind of API option where you can say, look, you really need to wipe this. I want ones and zeros and various passes and stuff. You just can't do it. So again, for public use, you'd want to think about what you put in the cloud there, because the engineer that takes that hard drive out that fails, 6 months down the line, it just depends whether you're comfortable with that situation. But that'll do. Distributed programming. Okay, we've been doing distributed programming for years. What's the difference? What difference does cloud make? Because now your developers have to code to the cloud platform, so these APIs, and most developers are used to client-server, the client-server paradigm. They're not used to dealing with events going on at lots of different places and how you basically deal with that. So I think we're going to see lots of security flaws come up just because developers they want to offer a cloud development service because that's what all the other development companies will do. And so I think invariably we're going to see some really interesting race conditions where they're making assumptions about they've checked something over here, but because the cloud provider is replicating it 3 times and they're using what they call eventual consistency, it means they're not all copies of the same value. So they rely on one figure, which has been like brought back from one shard, and they make a business decision on that. Let's say they're computing something, and that affects what the business does. But that was an older copy, and so you have this notion of eventual consistency, which means that your data is kind of in flux until it's written to all copies, say in a storage cloud. And so your developers suddenly need to be like, wow, okay, so is this the latest version that you're showing me here? You know, is this really the real value? And so, you know, it's another issue for developers, and I don't hold out much hope on that one. Cloud APIs, classic web services security problem. So you're going to have all the custom parsers that people create, you know, to deal with web services and stuff. You're going to have ways of authenticating, and ultimately you're going to end up with the famous answer right now, which is, oh, you want to do cloud programming? Yeah, we do SSL. We protect your API calls over SSL, and this is a table put together by Gunnar Peterson, and he just says, well, look, all these developers have been like using all this newfangled technology, and security people are still using network firewalls and SSL. And you might say, well, I'm using a web application firewall, and you know, we could argue about where the line is between kind of, you know, a lot of that subsumed into network firewalls in some cases. So when's the revolution coming? When are we going to change the way we do our security around applications? Well, the cloud providers are doing exactly that. Right, we've got SSL, we're good. So, free beer, anybody know who this is? Not the, you don't have to focus on the guy himself, but in the costume and everything, what would this person be representing? Close, but it's actually SS Elmo. You lose that one. All right, next beer question. Where is Tintin? Who knows who Tintin is here? Should be most of you, yeah? Yeah. Local cartoon hero. Do you know where he is? What's the building back there? Yep.
Kasteel van Molensloot.
Say again?
The Kasteel van Molensloot, the captain's castle.
Anybody else?
That's the right answer.
It is the right answer. So, in my accent, that would be like Marlin Spike, yeah? And we already know that SSL is like, we've been owned 10 billion ways by Moxie Marlin Spike. So if the cloud providers are trusting like SSL to be the solution to API security, like we've got huge problems. Now, obviously a lot of the stuff he found was about browser implementations, but what do the cloud management platforms, where do they run? Oh, they run in your browser. So another scary thing. Vulnerability research. These were some tweets that came out from DEF CON when SensePost were presenting their stuff. Did some really good research, and it really told you that the cloud providers are not monitoring API calls, like volume of API calls. They're not monitoring like how many credit card accounts are associated with how many user accounts. So again, it's just all like early days stuff, and this is why I think the cloud is like the wild, wild west right now. And so that's why I think it's really a fertile ground for doing vulnerability research. Here's another one, hypervisor stalking. So let's say you have a 0-day you have a hypervisor 0-day, but you need to be on the same physical host as the target. How would you do that in a cloud? A cloud that's made up of 10,000 physical servers running a whole bunch of VMs. So a team of researchers figured out how to do it with Amazon EC2. And so most of the time they can guarantee getting on the same, spinning up a virtual machine via an API call and being on the same physical host as the target. And so obviously from there you can do, straight away you can do denial of service when you're on the same physical host. But there's just like, this is a great piece of research, came out a couple of weeks ago. Of course on Amazon's website it's got we've become aware of a report and we're looking into it. Now it's not a vulnerability per se in Amazon, like you can't use it to immediately exploit something, but it's the classic thing which we see inside enterprises where people say, yeah, I'm going to call the machines after what they do, which is great for attackers, because it's great for admins, but it's also great for attackers. And the way that some of their administration practices and the way they allocate virtual machines kind of means that you shouldn't think, I'm in the cloud, so I'm kind of invisible. Yeah, like someone can't be on the same physical host. Well, they've proved that you can be. So call for researchers. I think, forget hypervisors for a minute, and I don't mean that. I mean, I still think it's a good area to look at, but it's like looking at hypervisor security is doing this. Yeah. So, and there's some really talented people that look at hypervisor security, but it'd be great if they also cast their eye a bit wider and looked at all this like newfangled software that's being kind of welded together. So, really I'd say again, you could be here next year talking about some actual hardcore stuff rather than my high-level flannel that I'm giving you now. Right, another beer chance. I need to finish in a minute. So, who is this enlightened provider? They're a cloud provider, which means that they're either infrastructure as a service, platform as a service, or software as a service. Who is this? Any idea? Because this is pretty radical. I mean, I didn't have space to put the conditions in. The conditions are reasonable if you're, it's fairly balanced. It's pretty reasonable. Anyone know who's got this policy? They only pushed it out a couple of weeks ago. No, you won't have them publishing this. Nope. Yes, Salesforce. That man wins a beer. Well played. Yeah, Salesforce did, and I want to applaud them in front of you guys, just to say, that's enlightened. Yeah, they're smart enough to know that researchers will have a pop anyway. They'll probably find some stuff, and what they're saying is, look, we're not going to prosecute you. There's some pretty reasonable criteria. Initially, I read the criteria. I was like, huh, that seems really limited. But then you can use your brain and think of a couple of ways to stick within those limits and still actually do useful research. So, that's really good, and that's the first provider I know that's actually saying this. Because how can we do vulnerability research, and actually disclose the results if we think we're going to get prosecuted? It's just going to either get hidden or it's going to be dumped on a disclosure mailing list. And then, with software as a service or any of these services, if it's dumped on a mailing list, it's like how fast can the provider scramble to fix the stuff? Because suddenly everybody's like, wow, I can just drain all the data out of this cloud provider because I've got this thing that's on a mailing list. So that's that one. Resources, bedtime reading. Probably won't want to read this tonight, but this is the best document in terms of security guidance right now. So if you're a defender and you're needing to think about cloud stuff because your CIO came along and said, we're going to go cloud, really you should get this. Version 2 is about to come out, and it's a major rewrite, so probably worth waiting for version 2. It should be the next week or two. Really worth a read, and if you want to be proactive, you can join this group as well. It's a non-profit group, and they accept vendors, customers. You don't have to be, or just individuals. So it's a great way to actually shape some of the advice that's going out there. This is my website. Feel free to visit. And this is Chris's website. Chris, genius, really smart guy, very entertaining blogger. Definitely read this. And yeah, so the end of the night, you've had too much. This is the same here. So for those of you that still have your eyes open, that should be. You don't need to change your glasses. Someone was hinting they need to change this. You'd have to change your eyes. That's it. We have finished. We've come to the end. You're free.
Okay, any questions?
I think there's one over there and one over there. We've got a race condition.
Okay. You mentioned the legal problems. In the US, I think it's the Patriot Act that allows the FBI to go to the data center and save some data. Do you know the legal situation in Europe and some countries?
The simple answer is I don't. There's ENISA. Do you know ENISA? It's the European Network Information Security Agency. So I'm in a group that's working with them to try and figure out some, it's called a risk assessment for cloud, and it's aimed at small to medium-sized businesses. And part of that has been to look at the legal side, and so they had their legal counsel look at that, and that, I believe the due date for publishing this thing is, I think it's like either October or November. So there'll be some specific legal advice in there, and it was specific to Europe, and I think it even noted, some of the country differences as well. Roger.
Okay. First of all, great talk.
Thank you.
You showed a slide about virtual private cloud from Amazon, and you have a small icon which shows some security. Do they define how they do security, SSL, IPsec, or do they offer maybe some, we run some MPLS VPN and it's secure, so because you are over the network transferring some information to different data centers, you don't know why, and is it feasible to do such some attacks like we showed in the MPLS?
It's a good question. Based on what they said, it was standard IPsec VPN, so they weren't talking about needing to deploy any additional devices. So they've got the VPN endpoint their side. Obviously, if you don't have a VPN endpoint, you need to deploy one. Now, there was no mention of, they didn't talk about, it's very brief, it just says industry standard IPsec, which obviously the devil's in the details, but they didn't mention anything about MPLS or anything like that. But yeah, Amazon tend to be fairly high level. They have a security white paper. If you're interested, you can. I think it's like Amazon AWS, Amazon.com, I think, and /security, and they have this white paper, and it's one of those things which I think it satisfies a lot of people. Like, it's got a fairly high level view on how they do security. But I think if you work in an enterprise and you look at that document, you're just like, wow, you've just opened up a can of worms. Like, there's so much stuff there which is kind of curious as to how they would do it, and some of the side effects of doing it that way. So they're very high level in what they publish, publicly. So all the people that want a beer, if you want to come up to me at the end, then I'll actually remember who you are, but please don't everybody charge.
Oh, we have one more question.
Oh, one more. Didier.
Yeah, Craig, I want to close. Last question. You, as a specialist, an expert in cloud and in beer, what is the proper amount, according to you, the proper amount of beer head?
The proper amount of beer head?
Yeah.
It depends which country you're in. If you're in England and you get served beer with a head, there's going to be a fight. If you're in Hungary and they serve, so I live in Hungary these days, if you're in Hungary and they serve a beer and it doesn't have a head, people think it's flat. Yeah. Over here, what have I seen? Well, last night I had quite a good introduction to, well, not really an introduction, but a good rerun of Belgian beer. But I don't think there was really head on. It wasn't on the degustation that we did. There wasn't really head on any of those beers when they were served. So I don't know. What's the correct answer? Do I have to buy you a beer and you show me? I could do that.
Okay, thank you, Greg.
Sorry, I didn't know the answer to that one.
I actually have another last question. I'm sorry.
Oh, hello.
You were showing an excerpt of a paper that was written on, I think from university or something.
Yeah.
That was written on how you could target an actual physical host machine. Could you elaborate a little bit on this technique, or is there a white paper that you would suggest to read?
Yeah, actually, if you go to my blog, I wrote a fairly extended piece. It's like the second or third oldest blog item. So just go to cloudsecurity.org. It's on the right-hand side. There'll be just like latest articles. You just click that, and there's a link in the first sentence if you just want to read the paper, or you can read my summary of it. But it's good, and there's the other stuff that's in the paper that I didn't really have time to mention, but I will now, is side channel attacks. I've always been fascinated by side channel attacks. I think they're one of the most interesting types of attacks that exist on systems, and it's really hard to eliminate side channel attacks. You have to spend millions like the military does. But there's side channel attacks obviously on virtualization, and So they've got some cool stuff. They didn't come up with anything like, wow, like this is groundbreaking stuff, but they moved the conversation forward about side channel attacks and virtualization. So that was cool.
Okay, thank you.